In this video, we are going to talk about the pigeonhole principle. If n plus 1 pigeon occupies n number of holes, then at least one hole has more than one pigeon. There are two versions in this pigeonhole principle. One is called basic version, other one is called generalized version. The basic version tells that if n items are going to put into m containers with the condition n is greater than m, then I can say at least one container must contain more than one item. Whereas the generalized version says that if n items are going to put into m containers, then at least one container contains at least n by m items. This symbol is called ceiling function. So when you look for ceiling function, you have to round up to the nearest integer. For example, if you have 21 items and you have 10 containers, that means we are going to divide 21 by 10. So that will give you 2.1. But we have to take the ceiling function of this number 2.1. So that means we have to round up to the nearest integer. So the nearest integer of 2.1 will be 3. So the answer is 3. This pigeonhole principle is used in computer science, number theory, and also in the field of geometry. Let us define ceiling function clearly. Suppose we have 4.2. Then the nearest integer to 4.2 is 5. So the ceiling function of 4.2 equal to 5. Suppose we have minus 1.7. The ceiling function of minus 1.7 is minus 1. Suppose we have ceiling function of the value 8. So since we have 8, this is the nearest integer. Suppose we have fraction 0.001. Then the answer is 1. Suppose we have negative integer minus 5. Then answer is minus 5. So for ceiling function, you always look for the nearest integer. An elevator can hold a maximum of 10 people. If there are 13 people waiting, how many trips must the elevator make to move everyone? So here the total number of people is 34. This we should divide by 10. So that will give you 3.4. So I am going to take the ceiling function of the value 3.4, that is equal to 4. Next example, a computer file is 512 bytes, but the storage system only saves the data of 200 bytes. How many blocks are needed to store the file? So here the total number of bytes is 512. I can save only 200 bytes. If I divide 512 by 200, we will get 2.56. Then I have to take the ceiling function of this value 2.56. So the nearest integer to 2.56 is 3. So I say 3 blocks are needed. Next example, how many people do you need in a room to guarantee that at least 2 of the people share a birth month? So here we treat the number of months 12 as pigeonholes. So how many pigeons are needed? Pigeon means number of people here. So if the first 12 people were born in all the different months, that means the first people born in the first month, second people born in February, third people born in March, fourth people born in April, like that. Okay, so that means all the first 12 people can occupy the first 12 different months. Then what about the 13th person? Then the 13th person must match any one of these 12 months starting from January to December. So he has to born, the 13th person has to born between either January up to December, any one of the month. So we have already 12 people plus 1 people extra. So that means 13 people. Another example, suppose you have a drawer full of blue socks and black socks. How many socks do you need to pull out to guarantee that you have a matching pair? So here we treat the blue socks and black socks as the pigeonholes. Then I am looking for the number of pigeons. So here number of pigeons is nothing but the socks which are going to pull out. So the answer is 3 socks, because by pigeonhole principle 3 socks and 2 colors, then at least one color must have 2 socks. So the answer is 3 socks. There are 28 different time periods during which classes at a university can be scheduled. If there are 567 different classes, how many different rooms will be needed? So here what I'm going to do, I'm going to divide the total classes by the time period. So we have 567 different classes divided by the total number of different period, 28. So that will give you 20.25. So if I take the ceiling function of this value 20.15, the nearest integer is 21. So I say a minimum of 21 rooms will be needed to schedule all my 567 classes.